the browser is our test engine, an automated browser, if you will. We call it a test-enabled web browser, which is based on the IE Trident rendering engine. So what we did with eValid was we wrote an awful lot of C++ code, and most recently it's all in Visual Studio 2008, soon to be this VS 2010. Underlying browser capabilities, we were able to emulate, and I'm going to be careful of the words here, emulate or imitate an IE browser. And so, for example, if you look at the help about for the product, I guess this is build 291 of V9, and the underlying browser, whoops, the wrong one, help system information. So the underlying browser is IE7. This is IE9 at this point. So this is a desktop application. The sole purpose of the eValid engine is to exercise. That means navigate to, upon, validate content of web browser applications. Now there are features in eValid that help it carry over to desktop apps, but it's primarily browser solution because we think everything you could ever want and need is in there. It's important to emphasize that this set of architectural features that it's implemented as a C loading the IHTML document model gives us a very low overhead and does not interfere with JavaScript. Now, obviously I'm going to repeat, it's redundant if I say asynchronous JavaScript and XML. So an AJAX application is one that uses the JavaScript engine. And then a couple of these we'll see later on where we write scripts that are several hundred commands that are very sophisticated JavaScript apps are really, really powerful. The important point in making this particular statement about no JavaScript interference is that I know there are other solutions in the marketplace that rely on a JavaScript playback approach. And the difficulty is that if you're doing server loading, which is what we're trying to do, if you use the engine that's part of what it is you're trying to test, then you've perturbed what it is you're trying to test by the fact of using the engine that's the underlying motivator for what it is that you're trying to test. So solution, you have to build your product so it steps aside and leaves the JavaScript engine alone and operates independently. And in fact, eValid does that. Now, I won't go through all of this, but I'll point out that there are all sorts of, and I'll just go through some of these. A key one that we'll come back to is validate and synchronize on a text string. Record time, and this is important for an AJAX app, to assure synchronization of playback. At record time, the recommended process is to include regularness in the recording so that at playback time, the playback is independent of how quickly or how slowly the AJAX application performed. I'm going to make a test here called test, and I'm going to test for AJAX. That's a good one to test for. AJAX technology. There we are. I want to go out of the area because I want you to see not all of the traffic that goes on. That is actually an AJAX application because that answer back that you're seeing, that signal. Here's a good way to tell. I'm going to just record, validate, select, validate, and synchronize on text string, and you see that eValid makes a recording, and the recording is very simple. This is another architectural feature of eValid, and that is all the interfaces are texts, text files, and programming skills isn't required. I mean, if I can do that example in the webinar, obviously it's not required. I'm really moving here into the next section because now let me show you what the script looks like. eValid as a browser can control the cache and the cookies, and the init link is Google, and the input value, and this is important to recognize, the record play paradigm here extracts from the web page these little factoids, like the input value was at Windows 0 at index 77, and the query string was Q, and that's the string I typed in, and this little extra set of arguments over here has to do with the frame path and some other details. This element blur and a submit click, and then here's the command sync on text. Now, sync on text will succeed, and we'll just go through and run this command and see if it succeeds. That was pretty quick, of course, but let's look at the, I won't do all these logs, but let's look at the log, the dialog, and you see that the, there was an adaptive playback step here. Because eValid is aware of how the DOM operates, at playback time eValid can do the right thing. I love to say do the right thing because you know, many times pages change, and a lot of these change relatively rapidly. But here is the synchronize on the save time after 31 milliseconds. So the synchronization logic made sure that this test worked no matter what. Now, that's important in a big, large-scale AJAX application because one of the things that might let me just rephrase that. One of the things that often happens is that people rely on wait time playback. Now, I'm going to use a prepared example. I've learned doing these seminars, as Rita said, we've done this for a year now, over a year. I've learned in these seminars it's never a good idea to expose yourself to too much, too many opportunities for goofing it up, because, you know, the way it works is if it can fail in the webinar, it will. So I'm going to use an existing example, and I'm just going to go through and play this so you'll see. This is the MooTools example, the autocomplete example on the MooTools website, and looks like I got a red screen. And I'm going to go back and change my preferences, because my preference, unfortunately, is left over from the last time. I'm going to change my preferences so the wait times that were recorded now are played back exactly realistically. They're not multiplied by, they're multiplied by 1, so that means they're, you know, eval will actually wait the 9 seconds. I've actually put a ceiling on this particular playback, so the wait times of anything over 3 seconds, 3,000 milliseconds, is I put a cap on that of 3 seconds, because otherwise it doesn't. In typing in, and let's look at this script. The script is important because notice I'm searching and I'm doing a search, and then I do an input value. So this is a condition for getting out of my sequence there. If I play this back with a wait time multiplier of 0, now you already saw the result, because what will happen, the AJAX is still loading things, and so the bottom part of that page isn't even there at the time the location of that, you know, by the time eValid tries to find the tag item, the tag of the search text box in the next search text box. Okay, adaptive playback can't compensate for that, and instead, what you have to use is, and now I'll go to the next section. Let's see if I've covered everything. Recording internal state. Sometimes the relative negative connotations to the record play paradigm, and our company basically believes that record play is useless unless you have two things: an extremely good recorder, which we believe we do, and 2, an extremely sophisticated playback engine, because otherwise, as everyone knows, recorded scripts fail. They're brittle. They don't work very well, and they fail for the wrong reasons, and your effort is lost. With eValid, we believe the recorded play engine is reliable enough that you can get useful work very quickly, and you don't have to be a programmer. So it's an easy scripting, easy to augment a script. You've seen that there are a lot of validation modes. I've shown you that. Let's go on now to the key part here of how to make sure that my little example works. So the first thing I'm going to do is show you again, I got these prepared. Pick up Moo2. Moo2 is the same example, except that in Moo2, and this has been hand edited. Let me just show you how easy this is to edit. I'll open that script up and put a blank in there and put a blank in there and save the script just like that. So these scripts are simple text files, and they just read so easily. You get used to a little bit of the syntactic sugar gets in the way sometimes, and sometimes the frame numbering. Here the frames are numbered rather than with names, but it's a little bit confusing. But in any case, the script can be easily edited. And what we did in this script was we took the command, which was await, which was wait time synchronization. Remember, wait time synchronization is dangerous for an AJAX application, and we replaced it with a sync on text. Now, that was actually done with what's called an insert recording. There's a mechanism for inserting a recording into an existing script, or you can simply edit that in because we know what we're looking for. Let's just single step through this thing and see where this goes here. We'll go to that page, and now you'll see the part. eValid synchronization for this page is complete, but the Moo playground is constructed by JavaScript that's running inside this top page. So we got to the end of the synchronization. The page is navigated, it's ready to act upon, but the contents of the window isn't there. So if I go now and just do a sync on text, the syncing on text is I'm looking for is this phrase right there, a country name. And I'm going to show you another little feature of the page map. I'm going to bring up the page map at this point and click on that phrase, a country name, and show you that that's actually, I'll show you. We do have sometimes problems with the page map in in these webinars because the webinar gets in the way of sometimes the Citrix webinar stuff gets in the way of the page interrogation logic. Let me try it again and see if I can get it. No, I'm not going to be able to get it, but let's just say, oh, well, there are some. Let me go up a little bit here to these things and find the one. Maybe I can get this one. There we are. In any case, if you're familiar with browser-based applications, you know what you're looking at. This is the entire contents of the DOM, and you'll please forgive me for the fact that the page map is trying to interact with Citrix and not behaving very well. But so I can go on and log file while we're playing back. All of this is done simultaneously, by the way, and I'll run this again. I can look at this log file and see that indeed all these, and now I'll single step through, and you see eValid then doing the input value, and eValid doing the second input value. All right, I get the screen better organized, so now you and do that, and I get a green screen. I'm going to run that by faster now so you can see what's going on. I'm going to put the script aside so you can kind of see the event log as it's being generated. So we're going to run that through quickly. We'll leave the event log top on the screen, and you can watch everything get recorded. These event logs, by the way, are also simple text files. The idea being that we don't know how you want to use the log data, but we put it all out there, and it's a simple, in a text file format. We actually have a version that will let you see that in HTML. I'll bring that up so you can see it. So this is the log, this is the event log in HTML, which is the same information. It's just been reformatted in the correct style. And you see we get a green screen. This test played back, and to emphasize what's going on, I played that back with a 0, playback, a 0 multiplier. So my wait time multiplier right there was set to 0. Right? So what I've shown you here is the principal cause of desynchronization of AJAX application is that the recording doesn't contain a synchronization step, and or the test engine relies incorrectly on wait times for synchronization. So what we do is we convert the page, we convert the script into one which is fully synchronized, and we did that with Move2. And we can sometimes, if we need to, and I won't necessarily explain how, but I want to take you over here to Move3. Move3 is an example where we went ahead and actually replaced the input value command, the first of the two input value commands, with what we'll call index motion or structural commands. The reason you would do this is if in the AJAX application, hypothetically, of course, this never happens to you. The joke there, of course it happens. If in the AJAX application, the field you want to type USA into moves around on the page and changes its name, or maybe its name is identified dynamically, or it's in a tag, or maybe 100 reasons why, you may want to be able to test that application independent of these minor changes. This page could be changing dynamically. It also could be changing after the page is loaded. The page might say, you haven't done anything for 10 seconds, so I'll download a new version. And I'm just taking a little side here into, we did screen content. I want to do just the DOM motion and manipulation commands. And I won't spend much more time on it than this to say that there's a screen to the top, which is index element 0. Then move the pointer to the element where you see the phrase local enter a country name. Okay, down, by the way, down the page means increasing DOM element indexes. I hope you understand that phrase, increasing DOM element indexes. Go down to where the tag input, and then input the USA into that particular input field. Let's just take that script down here, and I'll just single step through that one command, bring this up, and you'll see that this is the equivalent. Now, this isn't recorded from life. Everything in the original script that's commented out was what was from the from life recording. Well, it's still not ready yet, so didn't get past the init link. See, this is why the internal synchronization is working perfectly well, but we haven't gotten that page completed. It's still waiting for something. Oh boy, I hope we don't have the problem we had before, that AJAX static gets overloaded. In any case, the internal synchronization wouldn't proceed to the next command until this page is fully loaded, so we may not be able to get to my example. So let me stop that and move on and say basically let's just hope for the best. Is it still waiting for that, huh? Okay. So now we're halfway through the story. We've got one single test. Now performance, we've got one. Now how do we go from 1 to 10, 10 to 100, 100 to 1,000? Okay? Looks like we don't have AJAX Daddy not cooperating right now. How do we lift this now? Okay? I'll refresh and now it's waiting and now it will do it. Now we're okay. We've noticed that AJAX Daddy as an AJAX demonstration application does have some variable times, but we'll see what happens when we play with that. Okay, I've got a functional test, and the neat idea about eValid is that the same functional test, I mean the hard lifting is already done here, and I could use the test originally with a sync on text. I don't have to convert to the motion stuff necessarily, but I do have to have synchronization in place, because I'm now going to do a load test run, and the load test run has this little editor that looks like this, and if you click a load test run, you can do the following. I've got a prepared example that I'm going to use. Well, no, actually, let me use the real example here. I'll do it in real time. I'll type in moo3.evs. I hope I've got everything set up, and we'll call this load test webinar. All right, and I'm going to do a launch interval of 1/10 of a second. I'm going to basically run this with full browsers. I could run this without images as text, but I'm going to run full images, full browsers, and I'm going to run 5 at a time, and I'm going to repeat each one 5 times. So what this scenario editor says is that I'm going to pick a service level, full. I'm going to pick a load type, which is full. They're also thin and light. We'll come back to light later on. I'm going to repeat each script 5 times, and now I'm going to commit that to execution. And now you see I don't need this little utility any longer because the actual load test script is right here. And as you can see, there are, and I can open up the space there a little bit, there are 5. This is the script that's going to be run by the parent browser here, and there are 5 _evalid commands. So there are going to be 5 new eValid browsers launched. Each one is going to play back the moo3 EVS 5 times. And now, if I click one button and say, no, I don't want to save the last run, while this is running, we've launched the 5 browsers, and they'll all come up on the screen here, and I'll try to tile them away so you can see them all running. There's a load test monitor that shows up. I'm not touching anything, not doing anything, it's simply running. Takes a couple seconds for these browsers to launch and go to the first page. So let me pull these aside as they're running. So you got 3, 4, and there we are. I want to get as many of them on the screen for you as you can, so you can see all of these running. Now you might say to yourself, "Gee, what's going on? What am I seeing?" You're seeing 5 independent instances of the eValid test engine, each running the moo3 script, which has been, cleaned up and made very reliable, appropriate for an AJAX application, and you're watching eValid. These 5 instances of eValid all beating up on AJAX Daddy pretty hard, okay? We actually, I think, Whaley, are you on? What was the limit when we tried AJAX Daddy? Did we get to about 25 and it began to be crippled?
Well, I think not even that, probably around 10.
Around 10? So we have to be real careful.
Yeah, depends on the time when you use your site.
And after a while it begins to be very, very sluggish because, of course, there are what appears to the AJAX Daddy server to be 10 users simultaneously trying to do something with their server, and it really does slow down. Runs, we're 15 out of 25. It's recording the average, the total script playback time. Remember, I've got 5 scripts that are going to run a total of 5 times, and they're about 10 seconds each. So the average is 23, the slowest and the fastest times. And you might ask, well, why are we just recording the total playback time? And the answer is simple, simple, simple. In an AJAX application is what's the total playback time and the variance of the total playback time. Now, I separated these simulated users by 5 names. Wait till this what's going on. We think of this as 5 tracks of a railroad train. So the freight train going down the railroad, this ran 5 times. I'll just leave it there so you can see a total of 5 playbacks. If I had gone back to my load test scenario, and I'll show you how to do that in a moment, I could aggregate this lowest times, is because that's the easiest and the simplest way to get a good measure on the load that's imposed and how that load degrades, as you apply the load on the server. Now you might say, oh, that's really very interesting, but what about the performance monitoring? Where's the performance come? Well, we're willing to bet with our solution that your server is either IIS or the LAMP stack, and we made a conscious decision some years ago. We looked at the performance monitoring capabilities on a typical LAMP stack or on IIS, and we thought, my stars, there's no way we could ever duplicate as much sophistication as there is already on the server. So the part that's left out here is our side of this formula is the imposing of the load. The part that's left out is that we assume that somebody who's watching this load get imposed is going to be looking at the perfmons, and as the load is running, usually the loads are ramped up. I ramped them up almost simultaneously with 1/10 of a second between the starts, but you could put 5 or 10 or 30 seconds, 1 minute between those starts if you wanted to. Some other person, you, the test engineer, is simultaneously looking at those performance monitoring data, and from that you can see, are the servers hitting, what kind of page faults are there, what kind of page delivery fault levels are there, and all of the other kinds of things that are part of the performance monitoring area. Those are done. That's not part of what we're doing in the webinar today. We're talking about generating the load, and so we've done 2/3 of the way now. We've got a nice little load generation done. Practically speaking, when I've used the same test. Practically speaking, you could use any mix of tests, and I'll show you an example of that in a moment. There's no real practical requirement on the mix of tests except that they all should be what we call load test safe. That means if 2 or more of them is running, 2 or more are running it simultaneously, that they don't step on each other. Now, each eValid instance that can be, you can confirm load test safe by running a singleton test in minimized mode. Now, there is an eValid option for light, and let me go ahead and open up this EVL, and that was my load test move. I'll go back to here. I could have chosen to use these in light mode, and if I use the playback in light mode, I can specify number up to 1,000 threads. So this would be 1,000 simultaneous executions of the move EVS script, but that's the good news. The bad news is those executions don't do anything except process HTTP requests. Okay, so, or HTTPS. So eVLite is an option available in eValid, but it's an option that basically is used, and I'll just say it informally, we basically use the eValid eVLite option to keep the recording, keep the heads busy. Okay? Now, I said that we could maneuver things. Now, I'm going to open another EVL. No, I want to do this one, which is financial. In this particular case, sophisticated example, I won't run this because these tests, as you'll see in a moment, run for a very long time. But practically speaking, what I've done is I've chosen a, well, let me show you the other part of this, and that's this financial reporting survey. This table is the thing that I want to emphasize. It's this table that shows what's going on. There are 9 scripts, and this is what we would call a singleton run of all 9 scripts. Now, we know how long those scripts run. They run 300 seconds. Some of these run almost, gosh, that's almost 10 minutes. Okay, so these are very complicated scripts. Now what we are preparing for here is that we'll take the quote EVS script and we want to aggregate the data in that stack chart and the data in this report based on labeling all of those playback times into that particular column. All right. So when I actually do that, and I'll show you this case here, when I actually do that, then I know this is not a live one. I'm not going to try to do a test that takes several hours to run here on this webinar, but here you see the load test scenario monitor at the end of the run, and you see that we commanded, in this case, we took this load test script and we actually, it doesn't show here, but it actually, well, it could be, I could show it. Yeah, I can show that. Let me do that because I do have that. That's this one here. I took this 100 script example. So now you see the scenario with this 100. That's 100 simultaneous eValid browsers. Okay, I did 100 because if you do 1,000 on this screen, it looks pretty busy. And in fact, what we do is there's 100 running 10 times. So this is 1,000 playbacks, and this is the one that ran 124 minutes. And again, the very straightforward data, slowest and fastest script. And as you can see, we didn't get quite to 97. 65% of those actually completed before we stopped the test manually because we ran out of time. But at the peak load of this product, you can see that the variations are quite remarkable. That the scripts that had for example, publisher, which ran, where's publisher? The best one was loading. Okay. Now, I want to speak to the issue of lifting these scenarios to the cloud for a moment, and what we're able to do is, without any modifications at all or any magic tricks, get 100 browser users, 100 BUs. With a little bit of finagle script launch sequences, we can get 1,000 browser users on one machine. And we tried to get beyond 1,000, and I apologize, we were putting it on one computer. You're running out of resources pretty much totally. Anyway, so why does this become important to look at the cloud? Well, the cloud resource, as Rita pointed out in the beginning of the web advantages, there's high availability, extremely high availability, and very high bandwidth. All right. There's this progression of machine sizes here. I would say for 100 wide, you want to be on your local machine, and probably to do 1,000 users or eValid runs. But for 1,000 real browsers, you probably want to use what's called, I call it here very large RAM, the EC2. That's the Amazon EC2. Title for that is a quad extra large machine. And I'll just trot out some numbers for you. I didn't put this in the slide. But that particular machine runs a Windows Server 2008 data center operating system. It's an 8-core CPU. Each core the whole machine runs at 2.7 gigahertz. The machine has 68 gigabytes of RAM and has a 1 gigabit per second I/O capacity. Now, when you're running very large numbers of browsers, the natural question is, what resources do you run out of first? And we have a lot of experience with pushing the Windows operating system up pretty high. You typically run out of RAM first, and then you will run out of CPU time, and lastly you'll run out of I/O capacity. But the truth is you can actually get these things to run, and I want to turn this over to Whaley for a second, and we're going to show you a screen where, Whaley, will you take the screen and show everyone the example where we have was it 100 browsers running simultaneously?
Yes.
And we only are using, yeah, please do that. And then when you're done with that, I'll keep on talking, but are you there yet?
Trying to get my screen as a presenter to... Oh
boy. We don't want to... Oh, I don't want to hear, oh my God. We're going to have to drop that?
The GoToMeeting is overloaded with my 100 instances. Okay, show my screen. All right.
Show your screen.
Can you see my screen yet?
Yes, I see your screen.
Okay,
Okay.
here is the 100 by 5 wide. I'm going to make all the browser instances viewable side by side now.
So these are going to launch.
And basically, they all download a 1 kilobyte file and then go to the Google website. But
Oh, so we're going to watch this thing launch up to 100, right? So while you're
right.
while you're driving that, oh boy, we're going to wait for a second. How long does it take? A couple minutes
It takes
to launch
about
the 100?
5 minutes.
Okay.
But with
No,
okay,
that's
here
fine.
we have the 100.
I'll keep talking. You know. So there we are. There they all are launched, and
Here's what one looks individually.
and as you can see, the smallest image you can get of a browser shows just the top and the middle part and the scroll bar along the bottom. But go ahead and start everybody up. These are all synchronized in playback using a web page on our site, which can change from stop to go. So if you click go, the word stopped will disappear and be replaced with running. Will be replaced with running. Thank you. And now each of these playbacks, which was gated on seeing the word R underscore U underscore end, etc. on its script, they will all now start running. And so you will see this thing dancing around. Probably for a webinar, I mean, we it's our duty to show you this screen, and I know that you're watching it saying, yeah, did you guys fake this? And the answer is, well, no. But there's not much interesting to see when you have this many browsers running. And if you use a cloud machine and have 1,000 running, there's even less to see, because then the desktop doesn't even show them all. Actually, in a practical sense, you don't, in our experience, go to the level of actually launching this kind of a high load scenario until you've proved out, until you've done pretest, what I call in the outline, which you'll see in a minute, a lot of pretest validation to make sure the tests really do run. Experiment that the tests always finish. Now, you know they're going to take variable amounts of time, but you don't want to have tests be unstable and fail to complete. Or running this thing, then you want to make sure that you get the correct data. Oh, there's the load test monitor. You can see, if you see now what we've demonstrated, these are not aggregated. I could have aggregated them by groups, so if it was the same script running every time, but I could have aggregated them groups. Then you only see one line in that report. But now we did. Oh well, one didn't quite fit. Unusual, sort of not unusual for one to get hung up, 1 or 2 or even 5 or 10. You're really pushing the operating system to its limits. But the point is, there is the 100 wide playback, 8 scenarios that I showed you before. If you want to give me the screen back, Whaley, that's good. Thank you, Whaley. Do I press the button? Hello, do I press the button? Okay, give me my screen. So in this particular case where waiting for the screen so you see that. All right, so in this particular case, even though we ran 10,000 playbacks, this is min-max and average times for those individual scripts. Now let me show you something. Okay, so we're here, typical large machine. To go to 10,000 browser users, basically there we would use 10 instances in the cloud. But I've heard of some solutions where people, to get 10,000 browser instances, have to use 5,000 cloud images or 2,500 cloud images, and that's really difficult to manage. Practically speaking, you want to keep it to a small number of machines, and so here 10 images is pretty handleable. Another 2 comments to make about synchronization of starts. There are facilities in eValid to cause 2 things. You can cause all the tests in a group to wait for a particular external event. You saw that. It can also, those waits can also be done by waiting for a clock time. So you can launch, for example, launch 1,000 tests and have launch them all and have the first 1,000 start now, and the next 1,000 tests start in 5 minutes, and the next in 10 minutes, and then so forth and so on. So you ramp things up. And the other route is to take the 10,000 and launch them at 10 per 1 every second, 60 per minute, until you get to the, or I guess I want to use something like 10 per second, 600 per minute until you get to 10,000. The idea in both cases is to have the load imposed on the server grow linearly so that you can see what the degradation time on the server is using the perfmon data. So, okay, now, so let me summarize. We've shown you a 10 wide and a 100 wide, a 100 wide. For 10,000, you use multiple. We've looked at the load test monitor. We've looked at the collected data. These are the gross response times. It is also possible to collect this data with what are called timing splits within any test playback. And you do that by having each script write raw data into a text file, and then you can aggregate those all. There's a standard way of doing that we can talk about if you ask us about it.